Okay. So I was talking about the 3D wala arrangement. And I also said when you have something arranged like this, and in between these spaces we are arranging, right? Again, you have the A layer being repeated, B layer is in between. So on top of this, wherever you have spaces, we are placing another layer of balls or eggs or whatever, which are like spheres. Okay. So in the 3D layer, this is. And I also said I have showed you triangular words, how they are present in one layer. So let us now see the two alternative ways in which the spheres in the third layer can be arranged over the second layer. So you know the first layer and the second layer, right? I just drew. The first way was, this is the first layer, 3, 4, 5. Okay. In between you have 1, 2, 3, and 4. And again, this is all the bottom layer in which we are talking about the third row. Okay. So you can see these are the triangular voids like this. 2, 3, 4, 5, 6. If I draw a bit more clear, you could see the triangles. Last class I have drawn it. So on top of this, wherever there are spaces like this, we are trying to place. This is second layer. So the third layer in which you can place is, look at the first point. It is when a third layer is placed over the second layer in such a way that spheres cover the tetrahedral voids. The tetrahedral voids are nothing but why will there be no triangle? Yeah, so the tetrahedral voids are first of all triangular. Now, the first layer we can see triangle. On top of top of the second layer, these are the tetrahedral voids. In between, you'll have a tetrahedral void between those and the second layer. So they're going to cover the tetrahedral voids. A 3D closest packing is observed, or it is obtained, where the spheres in every third or alternate layers are vertically aligned. They are vertically aligned means what? That means the third layer is directly above the first, the fourth layer is above the second layer, and so on. That means what? You have a layer first, second layer is B. So arrangement is like A, B pattern, where the packing will be hexagonal closed packing, which is called as HCP, and it has a hexagonal symmetry. So which is called AB pattern. That means first layer will be in certain shape. On top of it, there's another layer. Again, the same layer is repeated on top of it. Again, the other fourth layer is repeated on top of it. So you have a same pattern wala 2 layers are just put one on the other. That is the first way of representing. I'll write the second point once you're done. Let me know if you're done. Can I clear the screen?
Yes.
See here, before it was similar A, next B, no? So when you have a third layer, it is placed over the second layer in such a way that the spheres are covering the octahedral voids. Means what, the triangular voids are there. On top of them, you put something. So there is a, we are covering those tetrahedral voids. Again, on top of it, there is some space, no? First layer, it is covered with something. And so those spaces are occupied. On the second layer, again, you have some spaces. That is called the octahedral. I remember I showed you today. Again, let me show you a picture for better clarity. So different from layers A and B is produced. Let it be layer C. Previously, it was A layer, B layer, again A layer, B layer. Now, it is not like that. You have A layer, B layer. C layer is placed in such a way that the spaces present in the second layer are filled with the third layer. Okay, let it be layer C. So, continuing further, a packing is obtained. A packing is obtained where the spheres in every fourth layer will be vertically aligned, to the spheres in the first layer. That means what? Again, the first layer is now repeating after third layer. Before it was the third layer itself is repeating like the first layer, but this is different. So This is called as ABC packing, which is also called as cubic closed packing. It was CCP before it was HCP. Remember, it is similar to face-centered cubic packing. And the symmetry which it has, before it was hexagonal, this is cubic symmetry. Cubic symmetry. I'll show you, I'll try to draw a diagram. Just copy this. You can understand and write in the way you want to also. Let me know if you're done. Please know if you're done, ma. At least someone, if you drop a message that you're done. Once you're done, we can go for. Have you done? Done?
This one.
Actually, I tried to draw it. I just wanted to show you this is the first layer, okay? So in the gaps, I filled 3 of them. It's a 3D structure, so obviously I can't draw properly. This is again the same layer. Okay, but the other one, it's like you actually have one layer, and in between this layer, you again have something which is filling like in between them. I cannot exactly draw them. The third one will be on top of it, how many ever are there. So it's like 3 different layers for the cubic close packing. If you want me to show a picture, See, so HCP and CCP is clear. This is clear. See, AB all C layers are same, CCP is different. See the see the you can see ABC layers. Here it's very clear. Anyone with a doubt can ask me. Right? See, A, B, B, A. Alternate layers. Here see A, C, B. Like from bottom also if you see it's A, B, C. Three different layers. See? Look at this part. A, B, A, B, A, C, B, A. This is very important. If you can take a screen, like if you understood, it's well and good now. Otherwise, for you to understand this picture, no, this is very, very clear, I feel. Okay. Now, in both CCP, cubic closed packing, hexagonal closed packing, okay, in both of these HCP and CCP of stacking that is done of spheres, a sphere, if you observe, is in direct contact with 6 spheres, with 6 other spheres in its own layer. Okay, it's like it directly touches. This is all very detailed. That's we are writing. It directly touches 3 spheres in the layer above and 3 spheres in the layer below. Okay, so the sphere will have the sphere will have 12 close neighbors. Close neighbors. So coordination number is only that one, na? The nearest neighbors or the one which is attached. So coordination number is 12 for both CCP and HCP. I want you to write down. So the one which is arranged as ABC, the one which is arranged as AB, both of them, the coordination number is 12. If you are done writing this, we'll now start with a concept called packing fractions. Yeah, can I clear? Yes. Now, topic is packing fraction. So, when you have seen both HCP and CCP above, okay, both of them are different patterns of packing. Okay, they are both different, but they are both different in patterns. Both are different patterns, but are efficient, equally efficient. Are equally efficient. So what happens now? They occupy, very important, they occupy the maximum possible space, which is about 74% of available volume. Hence, they are closest packing. Okay. Other than these two, there is a third type of arrangement. Third type of arrangement that is found in metals. That is body-centered cubic lattice. In this, the occupancy is only 68%. Okay, these are the two packing fractions. Just remember, you have to by heart. 74% and 68% you have to by heart. You have to remember the values. Let me know if you're done. Next we have, let us calculate of the different things, what is the space occupied. Okay. So, if you have a unit cell like this. Okay. I have lattice points. Lattice points. Let us assume this is A. Okay. So first I'm counting this, calculating this for a simple cubic unit cell. So if at all the A here is considered as the edge length of unit cell, and R let me consider as the radius of sphere, that is the atom. And you know that here the atom is like this, the atom is like this, atom will be like this, and atom will be like this generally. We know spheres are touching each other, which is the atoms. So the A, edge length is nothing but 2 R's, correct? So in this one, it is like a half and a half. This is 2R, R of this and R of this. So it is 2R or the diameter. And number of spheres per unit cell are how many? Number of spheres per unit cell, we clearly know it's 8 into 1 by 8 is equals to 1. If there is only one sphere, what is the volume of sphere? Volume. It is 4 by 3 pi r cube. So volume of the sphere is this. And if I want to know the volume of cube, it is a cube. Volume of cube is a cube. You already know a value, na? What is it? 2r cube. That is 8r cube. Okay. So the fraction of space occupied is 4 by 3 pi r cube divided by 8r cube. Now you see everywhere we are calculating it and getting the value as 52.4 percentage. You'll get 0.524, but the percentage I'll multiply with 100 now. Generally, the R value here is not, I mean, it is just calculated. So you have to know the derivation of it. Similarly, we'll derive for others also. For face centered, for body centered, everything for JEE. For NEET, now if you remember the values alone is enough. JEE, it's better that you know the derivation also. Okay, can I clear now? Done, ma?
Yes, ma'am. Yes, ma'am.
Face centered. Face centered unit cell. Face centered, what is there, ma? I have again the same cube, okay? Lattice points, which are atoms. Face centered, you have a face also, na? So if you see, this is the edge length A. And because face centered, you have to mix like completely these 3 atoms will be there. Okay. R is radius. Okay. A is edge length. Okay. There are 4 spheres in FCC. If you remember, 1 by 8 into 1 is the 8 is for corners, half into 6 is for the faces. So it is 4 spheres. So volume is equals to 4 spheres, each is 4 by 3 pi r cube. Okay, so in FCC, obviously the corner spheres are in touch with the face sphere. So if I actually name it as A, B, and C, D, the top one, we can see this is AD and this is A. No, sorry, C and D. This is C and D. So you can see the AD is equal to 4 times the radius of sphere. Why? You have a sphere here. So it's actually equal to 4R, which is 2 full spheres. If you see, there'll be full 2 spheres involved. So you can take AD is equals to 4R. Previously we have taken 2R now. So you can see now that ACD, let me draw. So ACD is a right angle triangle. In that case, your AD is equals to root over AC square plus DC square according to the Pythagoras theorem. You have A square plus A square, which is 2A square, so root 2A. Root 2A is equals to AD, but just now we already understood that AD equal to 4R. So root 2A will be 4R. Your A will be 4 by root 2R. Copy to this. Maybe I'll write here. So you have the third part. So we already got that A is equals to 4 by root 2R. And when you want the volume of cube, which is 4 by root 2R whole cube, you're going to get 64 by 2 root 2R. So what is the percentage? That's what we are now, percentage of space occupied now. So that is volume of sphere by volume of cube, same formula that we used in 200. So it is 16 by 3 pi r cube by 64 by 2 root 2 pi r cube in 200, which comes up to be 74%. These are the 3 parts. This is first, second, and 3. Let me know once you're done copying. Can I clear?
Yes, ma'am. Yes, ma'am.
The body A body center cubic